sklearnmetricspairwisedistanceschunked. Description: this function computes the pairwise distances between samples in a dataset in chunks. It's designed for handling large datasets where computing all pairwise distances at once would be computationally expensive or memory intensive. Inputs: X. This is the input dataset, typically a NumPy array or a sparse matrix. Each row in the dataset represents a sample. Y. This is the second dataset. If not provided, the function will compute distances between pairs of samples within the dataset X. Otherwise, it will compute the distances between samples in X and Y. Outputs: generator. The function returns a generator that yields chunks of the distance matrix. Each chunk is a 2D NumPy array containing distances between a subset of samples. Chunk size: this argument controls the size of the chunks that are yielded by the generator. Larger chunk sizes can lead to faster computation but may require more memory. Steps: data preparation. The function accepts either a NumPy array or a sparse matrix for X and Y. If a sparse matrix is provided, it will be converted to a dense matrix. Chunking: the function splits the input datasets into chunks based on the specified chunk size. Distance calculation for each chunk. The function computes the pairwise distances between samples using the specified metric. Yielding chunks: the computed distance chunks are yielded by the generator one at a time. Metrics: the function itself doesn't compute any specific metrics. It provides the infrastructure for efficiently calculating distance matrices in chunks, which can be used for various downstream tasks. Visualization plots. Heat maps: the yielded distance chunks can be used to create heat maps that visualize the relationships between samples. Dendrograms: hierarchical clustering can be applied to the distance matrix to create dendrograms that show the relationships between samples. Fine-tune parameters. Metric: this parameter determines the distance metric used to compute the pairwise distances. Available metrics include Euclidean distance, Manhattan distance, cosine distance, and more. N-jobs: this parameter allows parallel processing for faster computation. Specifying a value greater than 1 will use multiple CPU cores. Uncertainty methods. This function does not directly handle uncertainty. Challenges and fixes. Challenge 1: memory issues when handling very large datasets. Sample use case: computing pairwise distances between millions of samples, resulting in a distance matrix that is too large to fit in memory. Fixes: increase the chunk size to reduce the number of chunks processed at once. This can be done by adjusting the chunk size parameter. Consider using a sparse matrix representation for the input datasets to minimize memory usage. Challenge 2: slow computation time for large datasets. Sample use case: computing pairwise distances between millions of samples, resulting in a long computation time. Fixes: increase the number of CPU cores used for parallel processing. This can be achieved by adjusting the N-jobs parameter. Utilize a more efficient distance metric if possible, such as the cosine distance for high-dimensional data.